Hi guys, welcome back to YouTube channel Chemistry Live UGPG. Today we are going to talk about valence bond theory. So this will be highly beneficial for BSc Chemistry students under CBCS syllabus. So I have a simple message for you guys. Please think for innovation, be creative, learn everywhere, anytime and help to learn others. So this is the syllabus for Core 1 paper, Unit 4, Chemical Bonding. So let's discuss what is valence bond theory, Hitler-London approach. So usually what happens in ionic bond, the ions forming an ionic bond which are held together by electrostatic forces. But in covalent bond we know the covalent bond is shared mutually by both the electrons from both the atoms. But it is not clear what holds the two atoms together in a covalent bond. So to explain the nature of covalent bond, two theory was put forwarded. One is valence bond theory and second one is molecular orbital theory. So let's discuss valence bond theory. So this theory was given by Hitler London in 1927. So this is the representation of a hydrogen molecule covalent bond. So where hydrogen molecule has two electrons in that bond and one electron from each atom shared by equally by both the atoms. So if we consider the possibility of interchange of electrons between the two hydrogen atoms. So let's say this is HA, atom HA and this is atom HB. So HA and HB at infinite distance from each other so that no appreciable interaction may occur. So hence two possible equivalent structures for hydrogen molecule which are indistinguishable once the bond has been formed. So this is the way how we can represent HA electron 1, HB electron 2 and HA electron 2 and HB electron 1. So structure 1 and 2. So 1, 2 represent electron 1, 2 and here the electrons are exchanged. So if psi 1 and psi 2 are the wave functions for the structure 1 and 2 respectively, so according to valence bond theory, psi 1 will be psi A 1 into psi B 2 and psi 2 will be psi A 2 into psi B 1. So here psi A1, psi B2, psi A2, psi B1 are the wave functions for independent hydrogen atoms, namely HA1, HB2, HA2 and HB1 respectively. So the true wave function psi for hydrogen molecule is given by psi equal to C1 psi 1 plus C2 psi 2. So psi will be equal to C1 psi A1 psi B2 plus C2 into psi A2 into psi B1. This is equation number 1. So where C1 and C2 are mixing coefficients. For hydrogen molecule, C1 is found to be plus minus C2. So if C1 equal to 1, C2 will be plus minus 1. So hence we have two values of psi from equation number 1. So psi equal to psi A1 into psi B2 plus psi A2 into psi B1. So this is psi symmetric. And psi equal to psi A1 plus psi B2 psi A1 into psi B2 minus psi A2 into psi B1. So that is psi antisymmetric. So the psi S symmetric remains unchanged by exchange of electrons and psi antibonding changes its sign by exchange of electron. So if you plot the graph potential energy versus internuclear distance, so this curve is psi S or the bonding MO and this will be psi A antibonding. So this is antibonding MO. And here it is the internuclear distance R0 that is found to be 0.87 angstrom and E0 is found to be 3.14 eV electron volt. So from curve A, so this is the top one. If two electrons in HA and HB have parallel spins, so the energy continues to rise as the two atoms get closer together and no bond is formed. So in this case, no bond, in case of antibonding, no bond is formed. And psi A is repulsive or non-bonding state. So on the other hand, if two atoms have opposite spin, so energy curve S psi symmetric poses a definite minimum which corresponds to the formation of molecule. So psi S is attractive or bond formation state. So psi S symmetric at minimum, the calculated dissociation energy E0, that is the bonding energy, and bond length R0 are found to be 3.14 eV and 0.87 angstrom against experimental value 4.7 eV and 0.74 angstrom. Then improvement suggested by Pauling. So E0 value can be improved by considering two additional ionic structures for the molecule in which both the electrons 1 and 2 are attached to one atom. So hence two ionic structures are Ha minus 1 2 and Hb plus and Ha plus Hb minus 1 2. So this is structure 3 and 4. So let these structures be presented by wave function psi 3 and psi 4. So psi 3 will be psi a1 into psi a2 and psi 4 will be psi b1 into psi b2. So now psi becomes, by consideration of ionic structure, so psi s becomes psi a1 into psi b2 plus psi a2 into psi b1 plus lambda times psi 3 into plus psi 4. So we can put the value of psi 3 and psi 4 here. So you can see here. So psi equal to psi s, that is equal to psi covalent plus lambda times psi ionic. So in Baum used equation number 2 and found the values of E0 and R0 equal to 3.21 electron volt and 0.88 angstrom respectively for lambda equal to 0.158. So here lambda equal is the measure of degree to which the ionic forms 3 and 4 contribute to bonding, that is the degree of ionic character in covalent bond. So next comes the concept of resonance. So we know psi s equal to psi 2 plus psi 1 plus lambda times psi 3 and plus psi 4. So the two structure of hydrogen molecule cannot be represented by any of the four structures, namely 3, 1, 2, 3 and 4. What is considered to be resonating between two extreme structures, covalent 1 and 2 and ionic structures 3 and 4. So the actual structure or two structure of hydrogen molecule is a resonance hybrid of 1, 2, 3 and 4. So we can represent the covalent structure and the resonating structures as Ha1, Hb2, resonating between Ha2 and Hb1, and this will resonate between Ha minus 1, 2 and Hb plus, and it will resonate between Ha plus Hb minus 1, 2. So 1 and 2 are covalent structure and 3 and 4 are ionic structures. So when the properties of a molecule cannot be completely described by a single structure but by two or more structures, its true structure is said to be a resonance or mesomeric hybrid of these structures. So please subscribe to our channel Chemistry Live UGPG. This is also available in the website www.chemistryliveugpg.com. For class 11th and 12th, this is the channel Foundation Chemistry AB. So this is a simple step towards e-learning, making life better. Thank you all for learning.